So here's the Tiny Tetris. It's really easy to modify, and it can work with any screen, any processor. I just use the simple commands, all done in C here. So right now, I have it with an offset of 2 pixels on the X, 0 pixels on the Y, so it starts all the way up top. The block size is 10 pixels, so each little block there is 10 pixels wide, which means that that quadruple piece is 20 pixels wide, right? Right now I have the field set to 13 blocks wide and 23 blocks tall. I know that's not like regular standard Tetris, but yeah, so it comes over. That's the 23rd block all the way over here, right? Or the 23rd area over here. Comes down, right? This one doesn't really rotate, and it can plummet, right? Plummet again here. And so this little thing, I'll have a link to it. It has 2 little buttons already built in, but I added a couple more, and I'll have pictures on how I actually wired this up. Let's see. This one is keep dropping, and it supports multi-press. All right, snuck that in. Cool. Okay, so let's say if I wanted like the standard size, right? And so right now I can go all the way over to the edge here. Okay, this is 130 pixels wide by 240 deep. 135, 100. Yeah, I think it's 135 pixels wide. Okay, so let's say I wanted it 10 wide by 20 deep. There we go. That's all I got to change here. And then I hit upload. And it's going to take a second. All right, got a lot to think about. There it goes. Okay. And now I can only go over this far, right? Because it's only 10 blocks wide, the work area. And it only goes down to there. Okay. So pretty simple, right? So if I have a huge screen, I could make it either huge or I can increase the block size. So what did I say? It's 135 wide. So I'll make the block size, I don't know, 130. Let's see. 130. I'll make the block size 15, right? Kind of huge blocks. And I can fit 8 of those. 8? What is that? 8 times 15, 120? Yeah. Yeah, so I can fit 8 wide. And so let's see, 120, 135. So about 7 or 8 on the offset X to center it, right? And then 240 deep, 15. So what is that? 90, 180, 180, 205, 220. So that'd be 6 plus 6 plus 2 is 14 deep, right? So not that deep, but at least I'm filling up the screen here. Okay, there we go, and hit upload. And now the blocks are gonna get quite a bit larger. Let's see if I can get a line in here before it starts programming. Oh nope. There we go. Now we got these huge, funny looking blocks. All right. So it's this tiny little screen now, but now I don't need to wear my glasses. Let's see if yeah, the animations should still all work. They have animation, so this is a 2-line animation here. Whoops. Oh, I guess I'm further over than I thought. Okay, so 1-line animation just sort of goes side by side and clears it, right? There's a few animations in here, one for each size of line. And you might have to edit those in case you go to a different type of screen here. But we'll take a look at the code. Also, I guess first I'll make it like super tiny. So I'll make the block size, let's see, 8. Let's pull out a calculator here. Okay, clear this. Let's see, 130 divided by 8 equals So it'll be 16 wide. Let's see, 16 wide, 16x. Okay, 16 times 8 equals 128 out of 135, so that's 7 off. So I'll make the offset 4 to sort of center it. And then we have the score on bottom. I don't know if you can see that very well, but there's a tiny little score on bottom. Okay, so let's go with 230 divided by 8. 28.75. Okay, so field Y is 28. So this is this huge random screen, right, with all these tiny little blocks on it. We'll let that upload, and then we'll watch little blocks fall on the right. But let's take a look at the code here. So really easy, right up top, we have our offsets, right? Offset X, offset Y, in case you want to have like the scoreboard or the next part, next piece coming up, whatever. We have the block size, right? So the size of the actual blocks here. Yeah. Now I can move it way over. It's this huge screen. Okay. And then how many blocks wide is the field? How many blocks tall is the field? This is the actual piece array. And so it goes what type of block it is, rotation, the YX areas be each rotation. Yeah. It's this is probably the hardest part, mapping out each block. And at first, some of the blocks look pretty funny because I was way off on some of them. Anyways, okay. So block position X, block position Y, right? Kind of obvious. This one right here, our pins. These are our input pins, okay? So let's take a look down here what these actually are. So we go to, let's see, okay, this clears the lines. That's where all the animations are. New piece. Let's see, while it's waiting. So when it drops, it waits to drop the next one, right? And then it ups the timer, and the timer does get faster the more lines you clear. But here we go. So we got move left, move down, move right, plummet, rotate left, rotate right. And then I'll eventually add a pause and a reset to it. Okay. The pause, I didn't want a menu. I didn't want to, I don't know. Pause would be pretty easy to put in there. Reset would be extra easy to put in there. I just haven't done it yet. Right? Feel free to do it. You're going to have to make a program or a subroutine called pause and a subroutine called reset. I don't have that set up yet. But anyways, down here is all these little subroutines, right? Like what it actually looks like to move left. So if you can move left, then do it, right? If you can plummet, then do it, etc. Okay. So let's look at this again. Okay. Left, down, right, plummet, rotate left, rotate right. Okay. Let's go back up top and look at this. Okay, so these are all pull-ups here. Okay, input pull-ups. So, oh, there we go. Here we go. So, pin 15 is move left. Pin 0 is move down. Okay, pin 33 is move right. Pin 35 is plummet. Rotate left, rotate right. And then eventually this will be pause, this will be reset. So if you're on a nano, yeah, the nano doesn't go up this high, right? So you're going to want to change this to nano pins. And once you have those set in there, it'll set them as pull-ups and use them, okay? And then this is where it checks the screen or, creates the object of the screen. So right now I'm using SPI to talk to it. There's also ones that use I2C. Definitely go with a fast I2C. So when I first made this program, I designed it to use as little data sending as possible because I had neopixels and I had a ton of them. So each line was 2 strips of neopixels, 20 pixels long. And neopixels are kind of slow. So I had a 10 by 20 screen. Let's pull this up here. So 10 times 20, right? 200 neopixels, but each pixel was 400 or was 4 pixels. And so 200 times 4 pixels each. So there were 800 neopixels on this thing, right? Okay. So they talk at 800 kilohertz, right? So it should talk pretty fast, you'd think, but it's about 800 kilohertz. And it did kind of get a little slow when you're refreshing everything. So when you look at the screen here, it's not refreshing all these dots. It's only refreshing like a couple up here. It doesn't actually need to refresh these ones down here. And so as it goes down, it's actually only refreshing like 4 of these lines at a time. And so the only time it refreshes a whole screen is when you delete lines. Once you delete a line, then yeah, it refreshes the entire screen. Otherwise, it's just as few lines as possible. Okay? So you can talk to slower screens or have a slower interface. Just try to get it as fast as you can get it. Okay, so yeah, well, I'm using a TFT LCD and I'm talking to it through SPI, which is really fast. And so the object name is TFT. And make sure your library supports things like draw pixel, right? Or drawstring. The score is on drawstring. If you want, you can get rid of the score, right? In case yours doesn't support drawstring very well. And so it's under void scoreboard, drawstring, right? And so if yours doesn't draw string right, comment it out, right? And now as you upload, it'll get rid of the score there, and you can just play it. You can also now use that for your blocks, so you can bring your blocks down a little further. Okay, so that's that's the object here of the screen, right? And so you can fill it up here, right? If you have a huge screen with lots of pixels, you can make your blocks huge, or you can make your field size huge, right? Okay, let's go back down here. So yeah, it does need to support things like fill screen or clear screen. It might be fill screen, it might be clear screen. I don't know what the library supports, but you have this right here that actually draws something. Okay. The block draw. Block draw actually draws something. This one's set to 6-bit colors, which is not that many colors. And so it makes a random full value color with 6 bits. Okay. So it figures all that out here. It actually is it 5 bits? Yeah, it might be 5-bit colors that I have it set at. I think red is 6-bit. Otherwise, the other two are 5-bit. So 5 plus 5 is plus 6 is 16-bit, and you send a 16-bit value to the screen to make a color. Okay, so then we have the block size plus the offset. Right, you're actually creating the blocks here. It draws a rectangle around the whole thing at the full color, and then it dims everything by half. And then it fills the rectangle inside, right? I try to make it look like actual Tetris. And then it draws a little white pixel in the upper left, and then it draws a couple grayish pixels, sort of in the upper left, to sort of give it that shine. I wish this camera could pick it up better, but I guess not. Anyways, so that's where it shows most of the graphics here. Okay, the only other part where it shows graphics, except for the scoreboard, is right here, the clear lines. And so each line amount has different animations. So line 1, it just turns them off one by one, right? It just turns the block off. It's just what that's called. Turns the block off. I'll go down to that subroutine. Okay. This one, same thing, turns the blocks off, but it does it in a. Let's see. So it turns them all on fully, right? Turns them all white with the 2 lines, and then it randomly turns ones off and then turns them all off. This one changes all the lines, all 3 lines that you're clearing to different colors, and then swipes them off. Okay? And this one sort of does this rainbow animation. The 4 line does a rainbow animation and clears them all off. I think you can see that on my Instagram, like the 3rd or 4th video on this thing. Okay, anyways, so there's animations here, and then we need to find block or block off. So new piece creates a new piece. Waits to fall, but it's really just waiting for you to push a button, right? And if you do push a button, do something. Okay. And then show field. Yeah, shows the field, right? Using the block draw program. Okay. And then test to see if you can actually move or you win. Yeah, did I miss bluff? It might have been right next to it. Let's go back up here. Wait. New piece. Bluff. There it is. Okay. So it really just turns, well, it dims them or brightens them. It makes a gray square here. So it does a little bit of math to make a big old gray square. So it can be fully white to gray to off, right? Between 0 and 31. You give it a value between 0 and 31 and turns it fully bright to fully off. So I guess that's right before clear lines. And so that's another display thing. So if you're converting to neopixels, you're going to want to have your neopixels do this, right? Or if you're converting, whatever you're converting it to. Or if you're just using this screen, just hit upload, right? So you can make it as easy or hard as you want. Anyways, hopefully that explains how to hack this, right? If you want to understand the guts, I might explain, right? It's not that hard. You just have, there's 7 different pieces. There's 4 ways that rotate. There's an XY for each of the blocks, and each piece has 4 blocks. So it's not that much. And so as you rotate, now you're reading, like this line. Oh, rotating it. Now you're reading this line over here. Well, I guess let's see. This is XY. So this is XY of you rotating it. Oh, rotating it again. This is your XY of each block, right? So, I mean, it looks complicated, but it's not bad. It's not that bad. Okay, and then a couple simple commands, right? Like you're trying to move the thing left, right, up, and down. Well, you don't move it up, but really, if you separate it out into little pieces here, like move left, so it moves it over to the left, right? Well, it tests if it can move it to the left, and if it's true, it moves it to the left, right? Okay, and then it says show field, the current position -2, and the current position +3, right? So it shows about 5 pixels big of where it thinks it's at, right? Okay, move down. Let's see if it can go down any further from where it's at. If it can, then do it. See if it can't, then it collided, and so now it's going to run the collide, which will make a new piece. It'll set the piece there, set it in memory, and make a new piece, right? Okay. Oh, and you can keep pushing it too. And so if you hold it, it just keeps going down and down. I'll just show you that one here. So if I hold right, it doesn't keep moving, right? If I hold left, it doesn't keep moving. Okay. But if I tell it to go down, it keeps moving. Right? And so I wanted it to feel a little more like the actual game where it just keeps moving like that. And then it still got that plummet button. And you can't really see it, but it does actually animate as it goes down. And so, yeah, until it collides, keep moving down, right? So I've already got this move down button, or this move down program here, right? Which just keeps moving it down until it collides. So what I could do if I wanted to get a little fancier animation, I could put a delay here. Let's see, what would that delay be? I don't know, about 50? Sure. Okay. We'll upload that. And now you get to watch it plummet. Right, because the other one just had it go as fast as it could. This one there's actual delays. So now if I hit, that's really slow though. That's lame. Maybe 20. 20 would be better. Okay. Anyways, so rotate left. So it does a rotation, and if it fails, go back. Rotate right. Rotates it. test to see if it actually collides with anything or not. And if it does, go back, right? Show field, so it goes between every single uh, pixel in the field, every single piece of the array. Oh, here it goes. It just started. So I'll hit plummet. There we go. That's a much better plummet speed. It's better, but I think I'm going to set it to, I don't know, 15, 12. I'll set it to 12. Okay. I'll hit upload. Then we'll check back on it later. Okay. Anyways, so show field has two things it can do. It can just show the field, or it can show the field and the piece itself. Okay, so when you're clearing lines, you're just going to show the field, right? But if you need to also show the piece with it, wherever it's at, then it can show the piece. And so that's with this Boolean right here. So show field where you want it to start in the Y position, where you want it to start in the end, and if you want it to show the piece or not. The brick. Okay, here we go. Let's see if this speed works better. Yes, that's a good speed for our plummet. Okay, test to make sure it doesn't actually collide. If it does collide, return that it collided, right? And then we have a scoreboard. And so if we look at our clear lines here, it actually adds to the score. And you can change that all you want here. So there's a multiplier. So score plus equals multiplier. And then score plus equals 3 times multiplier. So if your multiplier is 1, which I think it's just set at right there. I remember in the original game, you could like start at level 5, and then you get a couple extra points for every block you get rid of. So I wanted to add that in here. And it's all 1 and 2 and 3. Like, it's not 100, 200, 300, which I think it is on the Tetris. And so it's a lot easier to, like, add multipliers if your base is 100 and your base isn't 1 like I did. But that's easy enough to do. You know, what would that be? So score plus 300 times multiplier instead of 3. Score plus equals multiplier. I guess multiplier would be 100, right? And then if you start on level 3, your multiplier is like 130 or 140 or something. Anyways, okay, so you get rid of 1 line, you just get a score of 1. You get rid of 2 lines, you get a score of 3. You get rid of 3 lines, you score of 8. And then when you're going for the Tetris, if you get a Tetris, you get 20 times. You get 20 points, I guess. 20 times the multiplier. Okay? And so you can change that if you want for correct scoring. I guess we can turn our scoreboard back on. Okay. Yeah. Okay. And I can change the font of this if I wanted. I could go up into setup. I think I have it in setup here. Let's check. That way it's actually like readable. Okay. Void loop, void setup. Nope, don't have it anywhere. Okay. Well, I know you can set it to a bigger font if you wanted. I just haven't. So it's not that tiny font. But now if I upload it, it'll show this tiny little print on bottom. So, yeah, I can make these as big and bulbous as I want. Can make them as tiny as I want. Really easy to modify. I can make it work with any screen I want. It's all in C, so it should go to any processor. Any processor through Arduino anyways. Right? So, not too hard to modify. And you got to pick your buttons. So I use the ESP32. Not all the buttons are pull-ups, but the ones I chose are pull-ups. And I just soldered little buttons to them. Right? So as you're doing this, I'll have pictures of, all the soldering and stuff I did too for you guys to look at. Anyways, thanks for watching. If you have any questions, ideas, upgrades, like, I don't know, if you want the blocks to look different, like, you can do it yourself, like under block draw, because, yeah, all it does is draw some rectangles and squares and little pixels to make it look like it's shiny in the upper left. You can make them be blobs, you can make them be whatever, right? So, I'd like to see what you guys do to it in case you decide to, mess with it. Or if you just get it working. I think that'd be cool to see. Thanks for watching, guys.